Hi, linear algebra students. So this video, unlike the previous couple of ones, is actually mandatory. So you have to fill in your notes with this example. And we're gonna just prove very shortly that the area of the parallelogram determined by two vectors u and v is actually the norm of its cross product. Okay? Uh, so just to understand why this formula is important before we move on, it is because it allows us to calculate the area of a parallelogram that doesn't sit nicely into R2, okay? So if the parallelogram is on a sheet of paper, meaning like that the vectors are in R2, then we can simply just use the determinant and we're good. But if it is in R3 like this is where we actually need the cross product. Okay, that being said, even if I say this, the proof relies on us to actually take that parallelogram. So I tried to draw it a little bit like in 3D, like even if that doesn't quite make sense. But look, the shadows here are here and here, so you can see like this is like tilted, and it relies on you just like putting it on a flat piece of paper in order to have a better visual aid. Okay, and the proof relies on this identity that we saw earlier in this class, in this chapter. So how does it work? Well, it's super simple. Okay, once we have that identity, that being said, remember that this identity is actually quite hard to prove. But once we have it, then this is quite the breeze. So if we look at the parallelogram that is here, its area is simply the length of u times the height h. Okay, so the area of the parallelogram let's actually say, just for fun, let's just say here. Okay, so the area of this parallelogram is simply, so will be the norm of u, which is this, multiplied by the height h. However, the height h, using basic trigonometry, is actually just the norm of v times the sine of theta. And you can say this even in R3, because in R3, as you can see, the h will be probably something like this. And the angle between the two vectors will simply be tilted like this. So it will be the same idea, right? So here you go. Let's put this down. So it will be the norm of u. And then as you can see, it's going to be the length of this side, which is the norm of v, multiplied by the sine of this angle. And as you can see now, well, this is just the formula for the cross product of u and of the norm of the cross product of u and v, right? So you have like u here, v here. And this is it, end of the proof. All right, hopefully this helps. See you in class or in the next video.